Space, the final frontier, a mysterious expanse that has captivated humanity since we first looked up at the stars. It's a place of wonder, filled with celestial objects that spark our imaginations and make us question our place in the universe. Hollywood, with its dazzling special effects and thrilling narrative, has often turned to space as a backdrop for epic adventures. But how much of what we see on the silver screen reflects the reality of the cosmos? Let's embark on a journey to separate fact from fiction, debunking some of Hollywood's biggest space myths. One of the most persistent myths perpetuated by movies is the sound of explosions in space. Hollywood has long fascinated us with its dramatic depictions of space battles, complete with roaring engines, booming explosions, and the cacophony of interstellar warfare. These scenes are designed to thrill and captivate, drawing us into a universe where the silence of space is filled with the noise of conflict. From the deafening roar of starships battling it out to the thunderous boom of planets colliding, Hollywood has conditioned us to expect a symphony of sound in the vacuum of space. These auditory experiences are so ingrained in our minds that it's hard to imagine space without them. The dramatic sound effects add a layer of intensity and excitement, making the scenes more engaging and memorable. However, the truth is far more serene. In reality, space is a vast, silent expanse. The calmness of the cosmos is a stark contrast to the noisy battles depicted on screen. The silence of space is profound, almost otherworldly, and it adds a different kind of beauty to the universe. It's a reminder of the vastness and the tranquility that exists beyond our planet.
Sound, as we know it, is a vibration that travels through a medium, like air or water. These vibrations create waves that our ears interpret as sound. On Earth, we are surrounded by mediums that allow sound to travel, whether it's the air we breathe or the water in our oceans. This is why we can hear everything from the rustling of leaves to the crashing of waves. In the vacuum of space, there is no such medium for sound waves to travel through. The absence of air or any other medium means that sound cannot propagate. This creates an environment of absolute silence, where even the most violent events occur without a sound. It's a silence that is both eerie and awe-inspiring, highlighting the unique nature of space. So, if a spaceship were to explode in space, it would be a silent spectacle, a visual marvel devoid of any accompanying soundtrack. The explosion would be a brilliant display of light and debris, but it would occur in complete silence. This silent spectacle is a stark reminder of the differences between the vacuum of space and the environments we are accustomed to on Earth.
Imagine witnessing a supernova, the cataclysmic death throes of a star. This event is one of the most powerful and luminous phenomena in the universe. The explosion releases an immense amount of energy, creating a dazzling display of light that can outshine entire galaxies. Yet despite its incredible power, a supernova occurs in complete silence. Instead of an earth-shattering kaboom, you'd experience a breathtaking visual display of light and color. Expanding outward in complete silence, the light from the explosion travels across the cosmos, illuminating the darkness of space. This silent light show is a testament to the beauty and mystery of the universe, offering a glimpse into the powerful forces at work in the cosmos. The absence of sound might seem counterintuitive, but it's a fundamental law of physics. Sound requires a medium to travel, and in the vacuum of space, there is no such medium. This principle is a key aspect of our understanding of the universe, shaping our perception of space and the events that occur within it. Space is a silent realm, a cosmic amphitheater where only light and other forms of electromagnetic radiation can travel freely. This silence is a defining characteristic of the cosmos, setting it apart from the noisy environments we are familiar with on Earth. It's a reminder of the unique and fascinating nature of space, a place where silence reigns supreme and light tells the story of the universe. Another misconception often portrayed in movies is the nature of explosions in space. Hollywood loves to show us grand, fiery explosions with spaceships being consumed by flames and shockwaves rippling through the void. These scenes are undeniably dramatic and visually captivating, but they are far from accurate. We're used to seeing fiery infernos with flames engulfing spaceships and shockwaves rippling through the air. These images are ingrained in our minds thanks to decades of science fiction films and TV shows. However, the reality of space explosions is quite different and far more fascinating when you understand the science behind it. While explosions in space are certainly powerful events, they unfold quite differently from their terrestrial counterparts. On Earth, explosions are accompanied by fire, smoke, and a deafening roar. This is because our atmosphere provides the oxygen necessary for combustion and sound waves to travel. In the vacuum of space, these elements are missing, leading to a very different kind of explosion.
The absence of oxygen, a key ingredient for combustion, means there can be no fire in space. Without oxygen, the chemical reactions that produce flames simply cannot occur. This is why, despite the dramatic depictions in movies, you won't see fire spreading through a spaceship in the vacuum of space. Instead, an explosion in space would manifest as a rapid expansion of debris, propelled outward by the force of the blast. This debris can travel at incredibly high speeds, creating a cloud of shrapnel that can be extremely dangerous to nearby objects or spacecraft.
Imagine a balloon filled with confetti suddenly popping. The confetti would scatter in all directions, much like the debris from a space explosion. This analogy helps us understand how the lack of atmospheric resistance in space allows debris to spread out rapidly and uniformly. Without air resistance to slow it down, the debris would continue to travel outward at high speeds, potentially posing a hazard to anything in its path. This is why space agencies closely monitor space debris and take measures to avoid collisions with operational spacecraft.
So, while visually stunning, explosions in space are more about the physics of expansion. The lack of sound and fire doesn't make them any less dramatic. In fact, the silent, rapid dispersal of debris can be even more awe-inspiring when you consider the forces at play than the fiery spectacle we're used to seeing in movies. Understanding the true nature of space explosions not only corrects our misconceptions, but also deepens our appreciation for the incredible and often counterintuitive phenomena that occur in the cosmos. As we continue to explore space, it's crucial to keep these realities in mind. The more we learn about the true nature of space, the better prepared we are to navigate and protect our ventures beyond Earth. Future missions will need to account for the unique challenges posed by space explosions and debris. By understanding the science, we can develop better technologies and strategies to ensure the safety and success of our journeys into the final frontier. The universe is full of wonders, and the more we learn, the more we realize how much there is yet to discover. Space explosions, silent and spectacular, remind us of the vast and mysterious nature of the cosmos.
Hollywood often depicts astronauts casually stepping out of their spacecraft without any apparent ill effects. However, the reality of exposure to the harsh environment of space is far more perilous.
Without the protective layers of Earth's atmosphere, our bodies would be subjected to the full brunt of the sun's radiation, extreme temperatures, and the lack of breathable air.
Imagine stepping out of your front door and instantly being exposed to the scorching heat of a furnace, while simultaneously being bombarded by invisible radiation and deprived of oxygen. That's a glimpse of what unprotected exposure to space would feel like.
Within seconds, our bodies would begin to shut down, with potentially fatal consequences. The human body is simply not equipped to survive in the unforgiving vacuum of space without specialized protective gear.
We often associate stars with their twinkling appearance in the night sky. This twinkling effect has fascinated humans for centuries, inspiring countless myths, poems, and songs. The sight of stars twinkling against the dark canvas of the night sky is undeniably enchanting. However, this twinkling is not an inherent property of stars, but rather an illusion caused by Earth's atmosphere. Stars themselves emit a steady light, but as this light travels through the layers of our atmosphere, it gets distorted.
As starlight passes through the different layers of our atmosphere, it gets bent and scattered in various directions. The atmosphere is composed of different layers, each with varying temperatures and densities. These variations cause the light to refract or bend multiple times before it reaches our eyes. This atmospheric distortion is what creates the twinkling effect we observe from the ground. The constant movement of air and changes in temperature cause the light from stars to shift slightly, making them appear to twinkle.
Imagine looking at a penny at the bottom of a swimming pool. The water's surface is constantly moving, causing the light to bend and distort the image of the penny. The water's movement would cause the penny's image to shimmer and distort, much like Earth's atmosphere affects starlight. This analogy helps us understand how the atmosphere can create the illusion of twinkling stars.
In the vacuum of space, however, stars shine with a steady, unwavering light, their true brilliance unobstructed by atmospheric interference. Without the atmosphere to distort their light, stars appear as they truly are, constant and steady sources of light. So while the twinkling of stars adds a certain charm to our earthly perspective, it's essential to remember that it's an illusion, not a true representation of these celestial giants. The next time you gaze up at the night sky, take a moment to appreciate the science behind the twinkling and the true nature of the stars. Understanding this phenomenon can deepen our appreciation for the beauty and complexity of the universe.
One of Hollywood's favorite space tropes is the perilous asteroid belt, a dense minefield of space rocks that spaceships must navigate with skillful precision. While asteroid belts do exist in our solar system, they're far less densely packed than movies would have us believe.
In reality, the distance between asteroids in a typical belt is vast, often millions of miles apart.
Imagine driving across a vast, empty desert with the occasional cactus or tumbleweed breaking the monotony. That's a more accurate representation of navigating an asteroid belt than the chaotic obstacle courses depicted in movies.
While collisions with asteroids are certainly possible, they're statistically improbable due to the vast distances involved. So while asteroid belts are fascinating celestial features, they're not the cosmic demolition derbies that Hollywood often portrays them to be.